example on this topic, that first order and second order differentiation or derivative of the function y or fx. So find the first two derivative, that is find the first order derivative and second order derivative of fx or y or fx at 1.1. So 1.1 is the point not given in the table. This point is not in the table. This point 1.1 lies between 1.0 and 1.2 from the following table. So we have to use the general formula, because what is the previous lecture first example, that find the first and second order derivative at the point 3.0, that is 3, and the 3 point is at the beginning of the table and is the present in the table. So if the value present in the table and at the beginning of the table, then what are the formulas used to find the first order and second order derivative? These are the formulas, that dy by dx at x is equal to x naught, this formula and this formula. These are the formulae used to find the first and second order derivative if the value is given in the table and value is at the beginning of the table. These are the formulas, that if the derivative at the point given in the table and at the beginning of the table, but if the values are given in the table and at the end of the table, then use these formulas to find the first order derivative and second order derivative. But if the point is not given in the table and the point is at the beginning of the table, then use these formulas, that is dy by dx for the first order derivative and second order derivative, and where this notation u is what? X minus x naught divided by h, that is u. So, and if you have find the derivative at the point not given in the table, that is, if you have to find the derivative of first order, suppose at second order, but the point is not given in the table and point is at the end of the tabular values, then use these two formulas. Okay. So now this problem number 2 is depend on these formulas. That is, the point is not given, but the point is at the beginning of the table, 1.1. So we have to go, we have to use these formulas. We have used these formulas for the example number 2. So this is the example, that find the value of first order derivative and second order derivative at 1.1. 1.1 is at the beginning of the table, but not given in the table. So we have to use the formula, general formula of first order derivative and general formula of second order derivative. And for that, use first prepare the forward difference table. So this is the forward difference table, because if the value is at the beginning of the table, then we have to use the formula involves delta square delta cube, and that's why prepare the forward difference table, first forward difference table. If the value is at the end of the table, then prepare the backward difference table. And so the first here is the value is at the beginning of the table, and so prepare the forward difference table. This is the forward difference table. So what is its first column? The values of x. The second column is the values of y, then delta y, delta square y, delta cube y, delta raised to 4y. If you observe the third column, then all the values are that is not third column, but third difference, delta cube column, this column, then all the values are what? Same. So no need to find further columns. So stop here, because all the entries in the further columns are 0. So no need to find the delta raised to 4y, delta raised to 5y, all the entries are 0. And this is the value of x naught, this is x naught, that is the first value. This is f of x naught or y naught, this is y naught, this is delta y naught, this is delta square y naught, delta cube y naught, and all the remaining are, that is delta raised to 4y naught, delta raised to 5y naught, all are 0. That is, we have to write the formula for first order and second order that includes third order difference. No need to write the further differences terms. So the formula, this is the formula dy by dx, this is general formula, 1 by h delta y naught 2u minus 1 by 2 factorial delta square y naught plus 3u square minus 6u plus 2 by 3 factorial delta cube y naught. No need to write the further terms of this formula, because the further differences, that is delta raised to 4, delta raised to 5, all are 0. And this is the formula used to find the general derivative, that is the derivative at a point not given in the table. So this point 1.1 is, which is lies between the 1.0 and 1.2, and so use this formula. So we have to find the derivative, first order derivative and second order derivative at 1.1, which is the between arguments 1.0 and 1.2, that is not given in the table, and so use this general formula. Then find the value of u and all this. So x, that is we have to find the value at 1.1. So x is 1.1, h is 0.2. What is the common difference? 1.0, 1.2, 1.4. The common difference is what? Is 0.2. So the difference between the distance between these two arguments is 0.2. So h is 0.2, and x naught, that is the first value of x, is 1. So x naught is 1 or 1.0, and then u is what? X minus x naught by h, that is x minus first point divided by common difference, and that is 1.1 minus 1.0 divided by 0.2, and that is 0.1 divided by 0.2, that is 0.5. So in the, if the point is given in the table, then no need to find the u, because u is 0 in that case. So if the point is given in the table at the beginning of the table or at the end of the table, then no need to find this u, because in the previous example, if you observe the previous example, then what is this? Is the forward difference table, and directly the formula for first order derivative at the first point is this, and there is no u in this formula because u is 0, and that's why no need to find u. Just write h and x naught, that is the first value, and directly substitute all these values, we get the first order derivative. Similarly, we get the second order derivative. But if the point is not given in the table, the point 1.1 is not in the table, it is in the range of the table, it is in the range of the values of x, and in this case write the general formula and find u in by using this formula, that x minus x naught by h, and it is what? 0.5. Then putting all these values in the this formula, that is dy by dx at x is equal to 1.1 is equal to 1 by h, that is 0.2 in bracket delta y naught. So what is delta y naught? This is delta y naught 0.128, and this is delta square y naught, this is delta cube y naught. So substitute all these values of u and these delta y naught, delta square y naught, delta cube y naught, and calculate all these calculation by using calculator. We get the answer 0.630. This is the first order derivative at x is equal to 1.1. And then second order derivative, to find the second order derivative, write the formula, general formula, d square y by dx square is 1 by s square, delta square y naught, this is the derivative of this function. So this is the delta square y naught, and 6u minus 6 by 3 factorial delta cube y naught. So no need to write the further terms, because all the differences of the fourth order and all the further differences are 0. And then substitute the value of h, and this is the d square y by dx square at x is equal to 1.1. Substitute h square and all these values, delta square y naught, delta cube y naught, and u, we get the answer 6.6. So this is the example that of the first order derivative and second order derivative. The point is not given in the example, as the point of view of examination or final examination. As far as that exam concerned, these problems are not so important, but these are in the syllabus. That's why we have to cover these types of problems. These type problems are important, that is the point given in the table and is at the beginning of the table or at the end of the table. But these problems are not so important as far as exam concerned. So this is the example of the point not given in the table, and we have to find the first order derivative and second order derivative. That is, we have to use these formulas. So these formulas, okay, if the point is not given in the table and at the beginning of table, then use this formula. So by using this formula, we have the answer of the problem number 2. And if the point is not given in the table and point is at the end of the table, then use these two formulas to find first order derivative and second order derivative. So here the point in the example point 2, point is not given in the table, that 1.1, and is at the beginning of the table, and therefore we have used these formulas. Okay, then next problem, the third number problem. So find the first and second derivative of the function tabulated below at the point x is equal to 2.04. So 2.04 is given in the table. This is the value of the argument x, but it is at the end of the table, or it is last value of the x argument x. Therefore, we have to use the formula of backward difference table, backward difference operator. That means we have to use these formulas. That is the derivative at point given in the table and at the end of the table. The point is given in the table and is at the end of the table. So we have to use these two formulas to obtain the first order derivative and second order derivative at last point. Okay, so prepare the backward difference table. So what is the difference between backward difference table and forward difference table? Entries of the forward difference table and backward difference tables are same. Just write in place of delta. We get the forward difference table from backward difference table. Okay, so here we prepare the backward difference table, not the forward difference table. So example number 3. This is the backward difference table because the value is at the end of the table. So what is the forward backward difference table? The first column are the entries that are the values of x, that is the first row as a first column, right? Second row as a second column, that is the values of y. And then del y, del square y, del cube y, del raised to 4y, and then find these entries. So this minus this is at this place, then this minus this at this place, then this number minus this number at this place. Okay, and this number minus this number at this place. Then again del square y is what? This minus this is at this place. And this minus this is 0, and this minus this is minus 0.0002. Then del cube y, this minus this at this place, and this minus this at this place, and then del raised to 4y is what? This minus this, so minus 0.0004. So this is the table, and then write the these two formulas to obtain the first order derivative and second order derivative by using backward difference formula. So dy by dx at x is equal to xn, that is the derivative at last point, is 1 by h del yn, 1 by 2 del square yn, 1 by 3 del cube yn, 1 by 4 del raised to 4yn. All terms are positive. Okay, so no need to write the further terms, that is delta raised to 5, delta raised to 6, not delta, del raised to 5, del raised to 6, all other further differences are 0. And then xn means last point is what? 2.04. That is we have to find the derivative at the 2.04. So 2.04 is the what? Xn. H is what? 0.02. If we observe the values of x, then what is the difference? That is 1.98 minus 1.96, or 2 minus 1.98. If we find this answer, then it is what? 0.02 is h. Then dy by dx at x is equal to 2.04. That is at the last point is what? This is 1 by h, that is 0.02, and del yn, del square yn, del cube yn. Substitute all the values from table. So what are the del yn? This is the del yn, last value. Then del square yn, this is del cube yn, and this is del raised to 4 yn. That is the last point, the last values. And then substitute all these values, we get the answer minus 0.1868. So this is the first order derivative at 1.1868. at one point. This is the problem, that is substitute all these values of this del yn, del square yn, del cube yn, del raised to 4yn at this place. Del yn, del square yn, del cube yn, del raised to 4yn. We get this answer minus 0.463. This is the first order derivative at the last point, at the point 2.04. Then second order derivative. So to find the second order derivative at xn, we use this formula 1 by s square del square yn del plus del cube yn plus 11 by 12 del raised to 4 yn. So this is the formula to find the derivative at the second order derivative at the last point. And then d square y by dx square at x is equal to 2.04 is what? 1 by 0.02 square, that is h square. And then substitute the values of del square yn, del cube yn and del raised to 4 yn from the table. So if you observe the table, these are the del square yn, this is del cube yn, and this is del raised to 4 yn at this place. And then answer is what? Minus 1.9. So this is the second order derivative at the point 2.04. So next example is what? Find the first and second derivatives at x is equal to 1.5, and this 1.5 is at the in the table. So at the end of the table, and so use the backward difference formula, and that's why first prepare the backward difference table. So what is the backward difference table? Write the first column, first row as a first column, second row, that is the values of y as a second column in the forward difference table. Then find del y, del square y, del cube y, del raised to 4y. So find all these entries. And now these entries are important. We have to find the value at 1.5. So at 1.5, this is yn, this is xn now. This 2.0 is not xn. We consider only table at up to this. We consider table up to this. That is either write here one line, dotted line, suppose. Then what are the entries? These entries are important. Right? This is xn. This is xn. And consider this 1.5 as a last point. Then this is yn, and this is del yn now, and this is del square yn, and this is del cube yn. Okay, so these values are important, and that is why to find the first and second order derivative at 1.5. So this is 1.5. This is the value correspond to 1.5. This is del yn. This is del square yn, del cube yn. Okay. So write the first backward difference formula for first order derivative dy by dx at x is equal to xn in 1 by h del yn, del square yn, del cube yn. So and then fourth difference is not for x is equal to 1.5. That is no need to write the fourth order difference term, that is del raised to 4yn term, because the differences of the fourth order and further higher order are 0 for this example. What is the table? This is yn. Now this is xn. This is yn. This is del yn, del cube, del yn, del square yn, this value, and this value is del cube yn. So further differences are 0, and so write only term up to del cube yn. So this statement is what? Note fourth difference is not for x is equal to 1.5. That is fourth difference, fifth difference, all the remaining differences are 0 for the point 1.5. So write the formula up to this del cube yn. Then xn is 1.5. Now consider this xn as a last point, and h is 0.5. If you observe the values of x, then what is the common difference is 0.5. So this 0 to 0.5, 0.5 to 1, 1 to 1.5, this difference is what? 0.5. So h is 0.5. And then dy by dx at x is equal to 1.5 is what? 1 by h del yn. So what is this del yn? This is the del yn, because this is xn now, this is yn, and this is del yn, this is del square yn, and this is del cube yn. So substitute all these values, del yn, del square yn, del cube yn from table, and then we have the answer minus 0.1868. So this is the first order derivative at the point 1.5. This 1.5 is not the last point actually, but it is given in the table and it is at the end of the table. So consider this 1.5 as a last point and solve the example. That is, use the same formulae that are used to find the value at the last point. So this actually 1.5 is not last point of the table or of the values of x, but consider this 1.5 as a last point. That is, consider 1.5 as a xn. This is yn, then this is del yn, del square yn, del cube y, and solve the problem. Similarly, the second order derivative, write the formula to find the second order derivative at last point, and it is 1 by s square del square yn plus del cube yn. No need to write the further terms because del raised to 4 yn, del raised to 5 yn all are 0. Then x is 1.5, h is again 0.5, and then substitute the values. And what is del square yn? So this is del square yn, this is del square yn, because this is considered as a last point, del square yn, and this is del cube yn. So substitute these values, del square yn and del cube yn, we get the answer 0.234. So this is the problem, that the point is not given in the table. Point is given in the table, but it is at the not at the end of the. It is not the last point of the value of x. It is at the end of the table, but it is not last value of the table. Last value of x. Last value of x is 2.0. And we have to find 1.5. So consider this 1.5 as a last point. Similarly, if the point is given in the table and it at the beginning of the table, that is, first suppose we have to find the first order and second order derivative at 0.5, then consider this 0.5 as a first point. So this is a, this is y naught, that is, this is x naught, this is y naught, this is what, del y, delta y naught. Actually we have to use forward difference table, delta y naught, delta cube y naught, and this is delta raised to delta square y naught, this is delta cube y naught. Okay, so if you have to find the value, so in next lecture we will see such a type of problem, that is the point is given in the table, but the point is not the first point of the value of x, and here is the problem, that the point is given in the table, but it is not the last value of x. So this first problem is what? This first problem is what? The value is the given in the table and it is the first value of x. And this is the problem, second number problem, the value is at the beginning of the table but not given in the table. This third problem is what? The value is the given in the table and it is last value of the table, last value of x. And this last problem of this lecture is what? This value is at the end of the table, given in the table at the end of the table, but it is not the last value of x. It is not last, it is second last value of x. And if it is the value of x is given in the table, but it is not in the first value of x, then also we have to find the first order and second order derivative. But such a types of problems we will see in the next lecture. So first solve this exercise. If we observe the first value, first problem, then we have to find the first order and second order derivative at 1.5. That is, we have to prepare the forward difference table and use the forward difference formula. Then next number problem is what? 2.03. This is the value between 2.02 and 2.04, and the value is not given in the table and it is at the end of the table. So for second number problem, use the general formula of first order derivative and second order derivative, that is these formulae, these are the formulae, and the value, the derivative at a point not given in the table and at the end of the table. So for second number exercise, use these two formulas to obtain the first order derivative and second order derivative at that point. Okay, that is, find u and all such values of del yn, del square yn, and all these. So for exercise number 2, use the general formula, because this value is not given in the table. This is not, this is in the range of the table, range of values of x, but this is not directly given in the table and it is at the end of the table. So use the general formula of first order derivative and second order derivative, and find the first order derivative and second order derivative at this point 2.03. That is where to you find u and h, all these things, and prepare the backward difference table. Actually, for this example number 2, prepare the backward difference table. For the first example, prepare the forward difference table. Then this value is at the center of the table. We have to find the value at 0.6. So prepare the forward difference table or backward difference table, any method useful to this. So my suggestion is that use the forward difference formulae. So prepare forward difference table and consider this 0.6 as a first point and solve the example. And then find f-1 for fx is equal to 1 by 1 plus x square using the formula, using the following data. So data is given actually, the function is also given, but no need of definition of function. Just we have to find the f-1 means the first order derivative at 1, means at the first point. So this is the 4 number problem is similar to problem number 1, that we have to find the first order derivative at the first point at 1. That is, we have to find dy by dx, y means fx, dy by dx at 1.0, and that is at 1. So f-1 means what? We have to find the value of first derivative at 1.0, that is at the first point. So prepare the forward difference table for this problem and use the formula to obtain the first order derivative at the first point, that is dy by dx at x is equal to x naught. So next number, now 5 number problem, we have to find the dy by dx and d square by dx at x is equal to 1.2. 1.2 is given in the table, and it at the beginning of the table. So first prepare the forward difference table for this problem, and then consider this 1.2 as a first point, that is x naught, and find the first order derivative and second order derivative. So the next problem, 6 number problem, find the derivative of first order and second order at 1.1. Again, this is given in the table and at the beginning of table. So this problem, 2 problems methods are same, that is prepare forward difference table and use 1.1 as a first point, that is x naught. Then next 7 number problem, dy by dx and d square by dx we have to find at x is equal to 50. So again, this is the first point, x is equal to 50. So prepare forward difference table and use the formula to obtain the derivative at dy by dx at x naught and d square y by dx at x is equal to x naught. So these are the answers of all these problems. So solve all the exercise, and if you have any problem in solving the exercise, communicate me with WhatsApp